Hey guys, I'm Randy. I'm a student here at the University of Maryland, College Park. I'm currently taking a class called Remote Sensing, and one of my big projects for this semester is to LIDAR map this entire helicopter. And if you're unfamiliar with LIDAR, it's essentially kind of like laser radar. Instead of it's just operating in the optical wavelength. So this is my target. It's a UH-1H Bell Huey Helicopter. This particular helicopter has seen action as a rescue helicopter, a surveillance helicopter. It's performed nighttime operations, and it has also been used for military training. As you can see, it's not in the best condition. There's some graffiti, just overall damage. It's been stripped, a little bit of rust, and that's kind of like why I chose this as my target. First of all, it's really cool, and second of all, I think it'd be kind of cool to, in a way, preserve it. So, before I get into the nitty-gritty of the LIDAR system, I'll show you guys around the helicopter more. So, this is the inside of the cockpit. As you can see, it's been stripped out, and there's a lot of damage and paint damage. So, I just want to give you guys a closer look into the inner workings of this thing. Okay, now that we got a tour of this thing, let me explain the procedure for how to LIDAR map it. So as you can see here, I'm facing the front of the helicopter. So when I were to map this, I would take several bread slices of just the profile. And from those bread slices, I'll get range measurements, which, when processed in a software such as MATLAB and MeshLab, will give me a nice view of the side profile. So, for example, if I had mapped it from the front, what I'll see when I process it, since I'm taking range measurements, is the curvature seen from this view. So, from here, I'll explain my LIDAR that I built, and I can show you the results that I've got mapping this helicopter with it. Hey guys, this is Randy here. I'm just showcasing my field deployable LIDAR that I built for my remote sensing class here at the University of Maryland. So as you can see, my LIDAR is Raspberry Pi powered. I have it built into an old box, and it just uses a standard cell phone charging battery block to power it. Within the device, like I said, there's a Raspberry Pi. I have a 7-inch Raspberry Pi touchscreen, so I don't require a keyboard or mouse. And on the back side, you can see the Raspberry Pi camera, which is 8 megapixel, and then this hole here is where I mount my laser. Inside, there is a little scope ring, which you can kind of see, which holds the laser. In the next section, I'll show you the internals of it so you could get a better idea of how it works. One of the major reasons I like my design is that it allows me to open up the device to access the internals, to troubleshoot, as well as just to make sure that everything's working correctly. As you can see, this here is the Raspberry Pi, and the screen is mounted to the back. Here is my laser mount, which is just a little scope ring that holds the laser. And in this corner, I have an Arduino, as well as an accelerometer circuit, which measures the angle of orientation, which is useful in calculating the range that the sensor is detecting. So this is the internals. I'll show you the data collection process in the next bit. Hey everyone, it's Randy here. I'm out at the helicopter. I'm LIDAR mapping the side profile here. As you can see, this is my new LIDAR setup. There's the laser, and I'm just going to briefly show you the data acquisition process. So at this point, the LIDAR is measuring the laser and the pixels from center. From the pixels from center and the X angle detected by the accelerometer inside the laser, it's taking a range measurement. So when I collect data, I just scan the sides up and down, and then I just take slices of the entire profile. That's pretty much how I do it. So now that you guys have seen the target, as well as the build of my LIDAR, I would like to show you the results that I got while scanning. So on this image, you can see the two-dimensional front profile in the top, and then the three-dimensional front scan of the profile. And as you can see on the 3D scan, on the left side, there's no data points where the windshield is. And this makes intuitive sense because on the real-life target, the windshield's missing there, which is what's creating that dark spot. This is the 3D mesh of the data. You can see the curvature of the nose leading up into the windshield, but it's kind of messy looking, and that seems to be a common theme with the Mesh Lab results. And here is the front profile with a red line drawn so you can easily see the curvature I was trying to show. So this next data here is for the fuselage, where in the case of like a Vietnam era Huey, where the troops and transport would be. So on the bottom in the 3D, you can see that the height of the fuselage is descending or getting shorter as you move closer towards the tail, which matches up with the real life image. So this is the mesh. Like I said earlier, the mesh has a lot of noise in it, but if you only look at the circled area, you can see the smaller and smaller height leading back towards the tail, as well as an indentation where there was a open door on the Huey. So here's the real life of it. It's not quite as nice as the cockpit, but I think overall it did reflect it, the curvature as well as the smaller and smaller height. So this final scan was for the tail. The 2D image doesn't make a whole lot of sense, but when you look at the 3D, you can see the tail getting narrower and narrower, and then on the very last line on the far right, you can see where the tail or the rear stabilizer sticks out. So in Mesh Lab, aside from that little noisy point at the top right, you can see the tail sticking out, which I think is pretty cool. And here's the real life version of the Mesh Lab, and you can see the Mesh Lab isn't perfect, but the Mat Lab in real life seem to correspond pretty well. Overall though, these are my results of the project. I think overall it was a really cool project to take a scanner built into a box using a laser pointer and a Raspberry Pi, and to be able to some degree accurately measure geometry of an object, especially an object as large as this one. So I hope you guys enjoyed listening in on my project, and if you have any questions, you can just comment in the section below.